Welcome! Today's lesson is 6.2. We're going to be subtracting with unlike denominators. Yesterday we added them, today we're going to be subtracting with them. So our essential question, how can you use models to subtract fractions that have different denominators? Investigate. Mario fills a hummingbird feeder with 3/4 cup of sugar water on Friday. On Monday, Mario sees that 1/8 of a cup of sugar water is left. How much sugar water did the hummingbirds drink? So we're going to use those fraction strips in the math board again. A, find 3/4 minus 1/8. So first we're going to place the 1/4 strip under the whole strip on your math board. So here's my 1/4 strip, or my whole, and then I'm going to place the 1/8 strip under the quarter strip. Let me move this up a little bit so you can actually see that. There we go. All right. So I'm going to find the fraction strips. So I have 3/4. So 1, 2, 3/4. Then I'm going to put my 1/8 underneath of it. This little space right here is going to be the difference. So if I can find a tile that can fit in that, it's going to tell me exactly what the difference is. And if you remember from yesterday with our equivalent fractions, I need to find a number that is in common between the 4 and the 8. Well, 4 can go into 8, so if I use 8 strips, I should be fine. So if I put 8 strips under here, I should be able to find out how many pieces I have. And if I look, I can fit one more 8 there. Remember, for every quarter, I get 2 8s, right? So let me put my line in between here. So I'm going to have 2 8s in this one. I'm going to have 2 8s in this one. So I'm going to have 1, 2, 3, and this is 4, 5. So the difference is right there. It's going to be 5 8s. So the hummingbird drank 5/8 cup of sugar water. All right, let's draw some conclusions. Describe how you determine what fraction strips, all with the same denominator, would fit exactly under the difference and what they are. So we talked about that a little bit yesterday. So trial and error, but you can also think about your multiplication facts. If you know that 4 goes into 8, because 4 is a multiple of 8, then that's going to help you. So knowing your multiplication facts is really going to help you to determine what the bottom number should be, because you want the bottom numbers to be the same. So let's look here. It says, try the largest fraction strips first to see if they fit exactly under the difference. Then try the smallest strips until a denominator whose strips will fit exactly as found. So in the problem that we had 5 1/8 strips, and that was our answer. Hot. Let's explain. Whether you could use fraction strips with any other denominator to find the difference, and if so, what is the denominator? Well, in this case, no. You couldn't, because there wasn't any other fraction strips that would fit. Sometimes you will have more than one fraction strip that will fit, and that's part of the reducing that we talked about yesterday, right? Where you're going to need to find the smaller number to be able to reduce or simplify. All right, let's make some connections. Sometimes you can use different sets of the same denominator fraction strips to find the difference, and all of the answers are going to be correct. So let's solve 2/3 minus 1/6. We're going to find the fraction strips, all with the same denominator, that fit exactly under the difference of 2/3 minus 1/6. So as I'm looking, here's my whole again. I'm going to compare it to my whole. I have 2/3 and I have my 1/6. So I'm trying to find what can fit inside this little hole. Well, I know that I can slide up 3 more 6, so the answer is going to be 3/6. Well, what else can I slide up into this hole? I could use force, and this would just be me. So I could use force in the hole, right? So I'd have 2/4 would be my answer. I could also use 8s, right? I could use 8s, and I would have, so these would be 8s. And I'm only doing this because I don't have the tiles with me, but when you have the tiles in front of you, you could see that 4 8s would easily fit under there, so that would be 4 8s. All of this is leading to simplifying, just like we used to do. So we say there's 3/6, right? Well, 3 goes into 3 1 time, right? And 3 goes into 6 2 times, so that's like 1/2, right? So that's what I would simplify these all to, 1/2. If I look at this one, 2 goes into 2 1 time, and 2 goes into 4 2 times. Again, 1/2. So see, I'm simplifying, and it's all simplifying to the same 1/2. Let's do the same thing here. 4 can go into 4 one time, and 4 goes into 8 two times. Again, I've simplified it. No matter how many times, whatever I put in this space, if I simplify it, I'm going to get it down to 1/2, right? Okay, on this next one, they've already put the answer is 7 tens minus 2 5s, right? So I have 1, 2, 3, 4, 5, 6, 7 tens, and there's my 2 fifths. What do I have left over? Well, it's kind of nice because it's already lined up for me. I have 3 tens, right? So my answer is going to be 3 tens. Let's look at the next one. So I have 2 thirds. There's 2 thirds, and I've got 1, 2 thirds, and I've got 1/4. There's my 1/4. So I need to find something that can fit in there equally. Well, what's the number that 4 and 3 have in common? It's 4 is not going to go into 3, and 3 is not going to go into 4. But I know that 4 and 3 can both go into 12, so I'm going to use the 12 blocks. And if I were to do that, and I'm not going to draw this very well, but if I were to actually use the 12 blocks, and I encourage you to please do that with the ones that you have, you're going to find that you have 1, 2, 3, 4, 5 of the 12 blocks that will actually fit in that space right there if you're setting the problem up on your own. All right, I need you to finish the on your own. You have problems 3 through 18 to complete. You can use the fraction tiles that are in your desk. I highly encourage you to do so. You can also work with a partner or meet me on the carpet. Good luck.